Hi everyone. In our previous lectures, we learned about data and how to organize it in tables. To represent data in a more better way, something that is quick, clear, and visually appealing, we use graphical presentation of data. So, today we are going to learn graphical presentation of data. In graphical presentation, we use diagrams and graphs to represent data so that anyone can understand it easily, even without reading all the numbers. So in this lecture, we will learn different types of graphs, including simple bar chart, multiple bar chart, subdivided bar chart, pie chart, histogram, and frequency curve. Each of these helps us understand data in a different way. So let's begin. To turn numbers into meaningful pictures, let's start with simple bar chart. This simple bar chart is drawn from this table. This table was our first table, which was this simple table, that is one-way table. So we use this table, and this was about marks of students, and we draw simple bar chart of it and pie chart of it. So this first bar is for this interval, the second bar represent the second interval, the third bar represent third interval, and so on. And the height of this bar represents this frequency, which is the number of students. So this height goes up to 10 for this first interval. This height goes up to 12 for this 10 to 20 interval, and so on. For the last interval 50 to 60, the height goes up to 6. Remember that on x-axis, this line is x-axis. You need, this is x-axis line, means where x-axis or independent data will be plot, and this is y-axis. Usually for frequency, dependent data usually plot here. So this is called y-axis. Even on x-axis and as well as on y-axis, the gaps must be defined equally. Like we are going from 0 to 5, then if we are taking 5 as gap, then we must go from 5 to 10, then must go from 10 to 15, then must go from 15 to 20. So each gap is of 5 units. Similarly, here once you define the gap, so it must remain constant or consistent throughout this x-axis. So here you can see a consistent gap. So here we wrote this 0 to 10 point. So this is from 0 and this is from 10, and this is the mid of this 0 to 10. This is 10, this is 20, and this is the mid of 10 to 20. This is 20, this point, and this is 30, and this is the mid, and so on. And you see that the bars are of equal width. The distance is of equal width. The first width may not necessary to be the same, but these width must be the same within the bars. And a bar is a rectangular array. So this is a rectangular array. So this is how to construct a simple bar chart. This is called a simple bar chart. Now comes the pie bar chart, or sorry, the pie chart. The pie chart for this marks distribution. So if you see, then this pie chart is drawn using a circle. So because this pie chart is based on circle, and these are the sectors. So the first sector, which is for 10 to 20, this sector is for, this blue sector is for 0 to 10. So 12.5% students fall in this interval. If you see 0 to 10, see this 0 to 10, so 10 students are there, and this 12 students is the 12.5% of the total students. So you calculate total here, then 10 divided by total multiply by 100 will give you this 12.5, and this sector you will draw by using this formula, value divided by total, this total, meaning you have to add all 10 plus 12 plus 17 plus 20 plus 15 plus 6, value divided by total multiply by 60, because we are adjusting it within 60, because this whole circle is of 360 degree. So 360, so you will get, if you do this for this first, that is 10 divided by, and here the total is, how many students are here, 10 plus 12 is 22, 22 plus 17 is 39, 39 plus 20 is 59, 59 plus 15 is 6, 7, 74, and 74 plus 6 is 80. So total are 80 students. So this total is 80 here. So each value, that is 10 divided by 80 multiply by 360. You can get this first sector. But this 12.5% you can get 10 divided by 80 multiply by 100, because this is percentage. But the sector must be drawn by using this formula. And you can use a protractor from your geometry box to calculate this sector. So this is how you can draw a pie chart and how you can draw a bar chart. The next graph is called multiple bar chart or subdivided bar chart. So for this we have taken this table, and this table was discussed earlier in the previous lecture, is a two-way table. We discussed that this is a double table or two-way table. So now we are going to draw a graph or chart. For discrete data, the graphical presentation is called charts, while in continuous data, the graphical representation is called graph. So this, the first graph made for it, and this is the second graph, means these two charts are drawn for the same data. So if you see, then sections are given on x-axis, while the number of students are again given on y-axis, whereas the sections are given on x-axis. So now again these are two bars, because these two bars represent two different categories. One is morning shift and the other is evening shift. So if you see this blue bar, then this is for morning shift. So this is for section A, the blue bars. Again, this is for section B. Again, this is for section C. And again, this blue is for section D. Then if you see, then this blue shows morning. So if you see this, the first morning number, which is 12, so the height goes up to 12, which shows that 12 students are there. Here 17 students are, and so on. So for section A, there are more students in evening. From graph you can easily pick that for section A, more students are in evening shift while less students are in morning shift. While for section D, more students are in morning shift while less students are, as compared to this morning shift, less students are in evening shift. And the or the minimum number of students are in section B in the evening shift. Similarly, the same graph can be represented like this, and this is called subdivided. For this, you need one stake, this one graph, and you need to sum one bar and you need to subdivide it. Now see, we just put this total. This is total 40. We just made a bar of height 40, and then the first goes up to 12, which is blue, and the rest left for the night shift or the evening shift. The same is plot here. So two-way table, or to draw graphically or to represent a two-way table graphically, we can draw these two charts. Then comes the subdivided bar chart. Again, this is the more complex, because our third table, which was multi-way table, was more complex than the above two tables. So if we see, then here are more categories involved, like sections A, B, C, D, in morning shifts having boys and girls, and evening shifts having boys and girls. So again, we made two bars or two staked for each one. The first one is for morning and evening shift, and the second stake is which is adjacent to this one. So this second one is for boys and girls. So first we represent morning shift total students, and then uh, morning shift with boys and girls. The same goes again for section B, the same goes again for section C, and so on. And here we define a key in which we are telling you that what this blue is for, this orange is for, and this green is for, and this uh, red is for. So here red is for night girls, green is for night boys, and so on. And this is how you can understand, or you can represent your table on graph. So this is the explanation what we have done. So I've told you that how we have constructed this multiple bar chart. So this is the explanation. Next comes the same which we construct in our last lecture, the frequency distribution, and we learn how to construct a frequency distribution. So from raw data we constructed this frequency distribution, and this was about income distribution of individual in millions, which were given in the raw data. So further I converted this graph into this. This I have 8 serial number because we made 6 classes for that data. Class interval the same, I copied here 9 to 18, 19 to 28, 29 to 38, 39 to 48, 49 to 58, and 59 to 68. Then I wrote tally here. This tally because we first count it, like No, this is not, because this is 9. We said that from 9 to 18, 12 individual folds here. So this is 5, this is 5, 5 plus 5, 10, and 11, 12. This is 5, 5 plus 4 is 9. Then this is again 5, 5 plus 2 is 7. This is again 5, because for 5 you need to draw 1, 2, 3, 4 lines and then one line above it. So this will make you 5. Then 5 plus 3, 8. Then 5 plus 2, 7. Then again 5 plus 2, 7. So this was 50. So in our raw data, total individuals were 50. So this is how we report or record the count this way. First tally, and then we convert this in numbers, which was called frequency. Next, we need class boundaries because we are going to draw histogram. The next graph is histogram. So histogram is the graph of adjacent rectangles. Like this is what? One rectangle.
One bar.
This line
This
must be
is
straight.
another bar.
This is another
This is the
rectangle.
third
This is
bar.
another rectangle. This is another rectangle. So adjacent rectangles, and adjacent rectangles brings continuity in the graph. If you see, then these graphs or bars are in gaps. So this type of data represents discrete data, while adjacent graphs
Adjacent
represent
bars or
continuous
adjacent
data.
rectangles.
So have to draw or have to calculate class boundaries from class intervals. So for this sorry, this subtract 0.5 from 9 and 8.5 to 18. Similarly, subtract 0.5 from 19 and 8 to 28, and so on. Subtract 0.5 from 59 and then 8 to 68. So this way we will get these. Here the limits are defined. If you see, then 9 to 18 means from 9 to and start from 9 and goes up to 18, means 9 and 18 are included. So from 9 to 18, this makes total 10 values. If you count from 9 to 18, then you are getting 10 values. So this is the lower limit, this 9, and this one is the upper limit. 9 is the lower limit and this 18 is the upper limit. But if you see to the class boundaries, then this 8.5 to 18.5 doesn't mean that from 8.5 to 18.5. It means from 8.5 to less than 18.5, because 18.5 starts again in the next class. So we will not go up to 18.5. Like here 9 to 18 means this x takes values less than or equal to from 9 to 18, means both are included. 9 and 18 are included, but in this case 8.5 to 18.5 means x is less than or equal to 8.5, but here less only, equal sign will not be applicable. So you start from 8.5, but you didn't go to 18.5. You have to go 18.5 less, and so on. So by subtracting 0.5 from lower limits and by adding 0.5 to upper limits, you will get this class boundaries, and this class boundaries will help in construction of histogram. So the class boundaries will be on x-axis, and the frequency, which represents the height of the bars, are plotted against y-axis. So if you see, then this is the first interval, 10 to 20. We define interval like this, and we went up to 70. We just define it, and then we adjust our bars within it. The first bar height is 12 because this frequency is 12, but its range is from 10 to
8.5.
20, but here start is taken from 18.5.
Starts is
So this
taken
is the
from
first start,
8.5.
18.5 to 8. This goes up to 18.5. This point is 18.5. Then again this starts, because this is adjacent, so again it starts from 18.5, and this went up to 28.5. So again start, because this is not counted as the upper limit, but this is counted as the lower boundary for the next bar, and so on. This way we completed our histogram uh, graph. So this is the construction of histogram, how we can construct a histogram by using class boundaries and frequency. Next one is frequency curve. We need a frequency curve again for representation of data. If you see, then this is more smooth than this histogram. So this is again, this is a way of representation of data graphically. So again, come back to our table, and here we calculated midpoints, because for this, for frequency curve, we need midpoints. And how to get midpoints? For calculating midpoints, you need to add lower limit with upper limit and then divide it by 2. You can use this column or this column for calculating mid values or midpoint. Midpoints is also represented with x, small x. So 9 plus 18 divided by 2 will give you first midpoint. Then 19 plus 28 divided by 2 will give you second midpoint, and so on. So again, you plot midpoint on this 13.5, which is this 13.5 is the first midpoint, and the height is 12. The second midpoint is 23.5, and the height is, again, if you just get down, then you will see that the first value is 13.5. As the gaps are defined equally, so or 13.5 falls here approximately. Again 23.5 falls here, then 33.5 falls here, and so on. So then you connect these dots smoothly. First point out the height with its corresponding midpoint, and then connect them. So this way you will be able to get your frequency curve, and this way we can say that this point or in this interval we have more students, and so on. So you can interpret your results accordingly then. Thank you.